Lesson 5. Artificial Intelligence in Cybersecurity. Artificial Intelligence (AI) in the cybersecurity landscape. Artificial Intelligence (AI) is a broad field of computer and data science focused on creating computer systems and software with human-like intelligence. This can include anything from solving complex problems to recognizing patterns and making decisions. Attackers use AI to increase speed, scale, and deception, while defenders use AI to improve visibility, detection accuracy, and response time. This dual use makes AI both a powerful tool and a growing challenge in cybersecurity. AI-powered attackers increasingly use generative AI, Gen AI, and machine learning to enhance traditional attack techniques. AI lowers the barrier to entry for cybercrime by allowing less skilled attackers to launch sophisticated attacks at scale. Automated hacking. Gen AI can automate aspects of hacking. This can allow cybercriminals to launch complex, large-scale attacks that are difficult to detect and counter. Security bypass. AI models can be trained to mimic user behavior or generate inputs that can trick biometric security systems, CAPTCHAs, and other AI-based security solutions. Phishing. Social engineering. Gen AI creates personalized content that mimics legitimate communication, tricking recipients into sharing sensitive information or downloading malware. Deepfakes. Audio or video created by Gen AI can impersonate individuals, influence public opinion, or conduct advanced social engineering attacks. Malware development. Gen AI can create malware that adapts and evolves to evade detection by traditional antivirus and malware detection tools. Exploits. Gen AI can analyze individuals, systems, and software for vulnerabilities to launch targeted attacks. AI-powered protection. To counter AI-enabled attacks, organizations increasingly rely on AI and machine learning to improve cybersecurity defenses. These technologies help identify threats based on behavior rather than static rules or signatures. Threat detection and response. Anomaly detection. AI algorithms can identify unusual patterns or behaviors that may indicate a cyber attack. Malware detection. Machine learning models can analyze files and programs to detect malicious software more accurately and quickly than historic methods. Intrusion detection systems, IDS. AI can improve IDS by reducing false positives and identifying advanced attacks that may bypass standard defenses. Predictive analysis. Threat intelligence. AI can analyze vast amounts of data from various sources to predict potential threats and provide insights into emerging attack vectors. Risk assessment. Machine learning models can assess the risk level of different assets and prioritize protection of the most vulnerable ones. Automated response. Incident response. AI can automate responses to certain types of cyber threats, reducing mitigation time and minimizing damage. Security orchestration, automation, and response SOAR. AI can integrate and automate multiple security tools and processes to streamline response to incidents. Behavioral analysis. User and entity behavior analytics (UEBA). AI can monitor and analyze behavior of users and entities within a network to detect suspicious activities that deviate from normal behavior. Fraud detection. AI can help identify fraudulent activities by analyzing transaction patterns and user behavior in real time. Adaptive security. Self-learning systems. AI systems can continuously learn from new data and adapt to evolving threats, improving their effectiveness over time. Dynamic policy management. AI can help create and adjust security policies based on the current threat landscape and specific context of the organization. Vulnerability management. Patch management. AI can assist in identifying critical vulnerabilities and prioritize patches to address them. Vulnerability scanning. AI-powered tools can perform more efficient and thorough vulnerability assessments. Limitations and risks of AI in cybersecurity. While AI is powerful, it is not perfect. AI systems depend on the quality of their training data and can produce false positives or false negatives. Attackers may also attempt to manipulate AI models through techniques such as data poisoning or adversarial inputs. AI should support, not replace security professionals and sound security processes. Machine learning versus deep learning. Machine learning ML is a subset of AI in which you teach a computer to recognize patterns by showing it lots of examples instead of giving it step-by-step instructions. If you show a machine thousands of pictures of cats and dogs and teach it which is which, it will start to notice patterns. Deep learning DL is a more advanced subset of ML that uses computer programs that act as artificial neural networks to analyze complex, unstructured data. These networks are inspired by how the human brain works, with individual layers rapidly passing along bits of information until the final layer puts everything together. Deep learning is particularly good at tasks like image and speech recognition because it can process and find patterns in very large, complex datasets. Inline machine learning improves cybersecurity defenses. Inline ML is the process of taking the analysis capabilities of deep learning and placing it inline, meaning security postures can be improved in multiple locations at the same time. The following features make it well-equipped to fight modern cyber threats. Threat detection capabilities trained by a large volume of real-world threat data. Analysis done inline to inspect real-world traffic as it enters the network. In the event of a security breach, inline ML is used to analyze and detect malicious traffic as it enters a network and block threats in real time at all detected endpoints. It runs in the background unnoticed, causing no disruptions to the device's workflow or productivity. Inline deep learning in cybersecurity. Inline deep learning applies advanced analysis directly to live traffic as it flows through the network, enabling threats to be detected and blocked in real time. In deep learning, AI selects an output or answer with the highest probability. This selection is based on its training, where it has learned which types of responses are the most likely to be correct in a given context. By operating inline, deep learning models can inspect files, communications, and network activity before malicious actions occur. This allows organizations to stop threats early, limit lateral movement, and prevent damage without disrupting normal operations. Inline deep learning is a key enabler of prevention-first security, allowing organizations to block both known and unknown threats as they appear. Because deep learning can continually evolve and learn over time from the volumes of threat data it ingests, it has become a key technology for predicting cyber attacks.